The world of lithium brines, a deep dive into salty resources. Greetings, fellow Earth enthusiasts. Ever wonder where the essential ingredient for your electric vehicle's battery comes from? While some lithium is mined from hard rock, a significant and growing portion comes from something far saltier and frankly a bit mysterious: lithium-rich brines. Imagine vast, salty lakes or underground reservoirs holding this precious element. This journey takes us into the fascinating world of these brines, from the famous salt flats of South America to the less explored lakes of Canada, delving into how they form, how we find them, and the unique challenges and opportunities they present. Lithium has become a superstar mineral, absolutely vital for the clean energy revolution. The demand is skyrocketing, primarily driven by the insatiable need for lithium-ion batteries in everything from smartphones to electric cars. Meeting this demand sustainably is a major global challenge. Traditional hard rock mining has its downsides, including environmental damage and health risks from excavation and chemical processing. This pressing need has spurred innovation, leading to the increasing focus on recovering lithium from salt lake brines and other aqueous solutions. Lithium resources come in a few main flavors, but brines held in closed evaporitic basins, often called salars or playas, currently hold the lion's share of known global resources. These environments are typically found in arid climates where evaporation rates are sky-high. But lithium can also be found in other types of brines, such as those in sedimentary basins. Think deep underground aquifers, sometimes associated with oil and gas production, yielding produced waters, and even geothermal systems. While sedimentary basin and geothermal brines aren't yet commercially produced on a large scale, they are emerging as potentially important sources. Closed basin brines, nature's giant evaporation dishes. Let's zoom in on the most significant brine type: closed basin brines, found in places like the stunningly vast salt flats of the Lithium Triangle, that special corner of Argentina, Bolivia, and Chile in South America. These areas are home to over half of the world's known lithium resources. Picture this: enormous inland salt flats sitting in basins with no outlet to the sea. Water flows in, often bringing dissolved minerals weathered from surrounding rocks, but the only way for the water to leave is through evaporation. And boy, does it evaporate in these arid climates. This relentless process concentrates the dissolved salts, including lithium, in the remaining brine, often accumulating in shallow subsurface aquifers beneath the salt crust. These salars are the result of a long history, sometimes starting as freshwater lakes thousands of years ago that gradually became salty and eventually dried out. Geological factors like the weathering of lithium-bearing rocks in the surrounding mountains and tectonic activity play a crucial role in supplying lithium to these basins. Volcanism in the region has also contributed a massive transfer of ions, resulting in significant volumes of various salts. The Salar de Atacama in Chile and the Salar de Uyuni in Bolivia are prime examples, immense landscapes where lithium extraction is a major focus. The Salar de Uyuni, for instance, is the world's largest salt flat, sitting at a high elevation. Understanding the hydrogeology, essentially how water and brine moves underground, is absolutely key in these systems. It's not just about the salty crust you see on the surface. Lithium is highly soluble and doesn't easily precipitate into solid salts during evaporation. Instead, it tends to stay dissolved in the residual brines, often collecting in aquifers in the shallow subsurface. The movement of groundwater, the recharge and discharge zones within the basin, and the properties of the rock and sediment layers, like how porous they are and how easily water flows through them, known as hydraulic conductivity and permeability, all control where the lithium-rich brine ends up and how concentrated it becomes. Researchers use sophisticated hydrogeological frameworks and models, integrating data from geological maps, satellite observations, and even climate information like precipitation and evaporation rates to map this complex subsurface plumbing. Beyond the sailors, lithium in unexpected places. While the lithium triangle dominates the current brine scene, other locations and types of brines are gaining attention. Sedimentary basin brines, for example, are found deep underground in confined aquifers. These brines often have very high total dissolved solids, meaning they are super salty, but the lithium concentrations are typically lower compared to the most concentrated salars. Interestingly, they are frequently associated with oil and gas production, sometimes being extracted as a byproduct, produced waters. Places like the USA and Canada have documented these types of brines. Although not yet in commercial production, the advent of direct lithium extraction, DLE technologies, which are designed to selectively pull lithium out of lower concentration solutions, makes these sedimentary basin brines more viable potential resources. They might even be more environmentally friendly than traditional mining, potentially requiring less land use. Speaking of Canada, let's take a peek at southern Saskatchewan. This region is known for its numerous sodium sulfate-bearing lakes, where minerals have been mined for decades, dating back to the 1920s. While the major elements in these unique lakes are well documented, there's surprisingly little public information about the concentrations of minor elements, especially lithium. A recent reconnaissance study decided to tackle this gap, sampling both stockpiled chemical sediments and, crucially, the lake brine itself from many of the larger lakes. Sampling brine from these lakes isn't always easy. Sometimes you need creative solutions, like a throw bottle, to collect samples from the main body of the lake away from the muddy edges. This study aimed to provide foundational data on these previously underdocumented minor elements. Just like in arid salars, lithium's high solubility means it could potentially concentrate in these Saskatchewan lake basins over time due to continuous input and evaporation. Finding and evaluating the salty prize. So how do geologists and explorers find and evaluate these hidden brine treasures? It involves a multifaceted approach, combining various scientific techniques. Geochemistry is fundamental. Analyzing the chemical composition of the brine itself is obviously essential to know how much lithium is there, as well as other elements that might be valuable or problematic to extract. Studying the chemical sediments deposited in the lakes also provides clues. Hydrogeology is equally critical. You need to understand the groundwater flow paths that bring lithium into the basin, how the brine is stored in the subsurface, think aquifers and their properties, and the overall water balance influenced by factors like rainfall, evaporation, and inflow/outflow. Geologists use techniques like drilling boreholes to collect brine and rock core samples and conduct pumping tests to understand how the aquifer behaves. Hydrogeologists essentially become the mine engineers for these liquid resources. Geophysics plays a vital role, especially in the early exploration stages. Techniques like electrical resistivity or seismic surveys can help map the subsurface structure, identify potential brine-bearing layers, and understand the basin's configuration without having to drill everywhere. This can significantly reduce exploration costs. Remote sensing and modeling are increasingly valuable tools, particularly for evaluating vast remote areas like the high Andean salars. Satellite data can provide information on surface conditions, elevation, land cover, and even help estimate evaporation. This data, combined with geological and hydrogeological information, feeds into sophisticated computer models. These models help scientists understand the processes driving lithium concentration, predict where higher concentrations might be found, and simulate how a brine resource might behave under extraction. It's like creating a virtual plumbing system for the basin to see where the good stuff accumulates. Putting all this information together is necessary not just for understanding the geology, but also for formally defining a lithium brine deposit. There are international regulatory frameworks, like Canada's NI 43101, the JORC Code, and SEC guidance in the U.S. that set standards for reporting mineral resources and reserves. These standards, initially designed for hard rock deposits, have been adapted for brines. Key factors for estimating how much lithium can actually be extracted include the volume of drainable brine, related to the rock's porosity, the concentration grade of lithium in that brine, and the properties of the reservoir rocks like permeability. Challenges and the human element. While the potential of lithium brines is exciting, their extraction isn't without challenges. Environmental and social considerations, often grouped under ESG, environmental, social, and governance, are extremely important, particularly in sensitive areas like the lithium triangle. Water is often a scarce resource in arid salar environments, and the extraction process, especially using evaporation ponds, can consume significant amounts of water. There are concerns about the impact on local water supplies and ecosystems, including sensitive wetlands. Indigenous communities often live near these resources, and issues around water access, land rights, and effective communication are crucial. Historically, information provided to communities has sometimes been highly technical, difficult to understand, and solely sourced from the mining companies themselves, leading to distrust. Building strong, respectful relationships with local communities early on and ensuring transparent, accessible communication is absolutely vital for any project's success. Looking ahead. Lithium brines represent a significant part of the world's lithium supply chain, essential for powering the global shift towards clean energy. Understanding their origin, how lithium concentrates within them, and how to responsibly explore and extract this valuable resource requires expertise spanning geochemistry, hydrogeology, geophysics, and increasingly, remote sensing and advanced modeling. As the demand for lithium continues to grow, further research and the application of innovative techniques will be crucial to sustainably unlock the potential of these salty treasures, whether they lie beneath the vast salars of South America or the unique lakes of Saskatchewan. It's a complex but incredibly important field, driving both scientific discovery and technological advancement.
Welcome to the world of geology and earth sciences with Ricardo Valls, a seasoned professional geologist bringing you over 1,500 videos of unparalleled expertise. Whether you're a budding graduate student, an early career specialist, or a seasoned professional, this channel is your gateway to a wealth of knowledge. Explore a vast array of Earth-related subjects, including geology, geochemistry, structural geology, and the application of artificial intelligence and machine learning in geosciences. Ricardo Valls not only shares his own invaluable insights, but also brings you exclusive interviews and collaborations with other prominent geologists, offering a comprehensive view of the field. Stay ahead of the curve with our latest content, covering everything from unraveling the Earth's secrets to exploring global geological phenomena. Don't miss this opportunity to enhance your knowledge and stay at the forefront of the industry. Subscribe now, hit that like button, and share this invaluable resource with your colleagues and friends. Join our growing community of over 2,000 earth science enthusiasts and professionals today. Unlock the secrets of the Earth with Ricardo Valls, your top resource for all things geology. The future of geosciences is here. Be part of it.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.